All right, so our last topic we're going to look at in trig is logarithms. Okay, and basically the simplest thing you can really do with a logarithm is take a problem like that and solve it. Okay? What do you notice about this problem that makes it a little bit harder than like kind of a basic algebra 1 problem? You wouldn't see a question like that in algebra 1. You might see a question like this in algebra 1, but not like the first one I wrote. Okay, there's an exponent. Let me give you something a little different. That one has an exponent too. Yeah. Yeah, the key is there's an exponent, but the exponent is a variable. Okay? So anytime that you have an exponent that's a variable, that's where logarithms come in. Okay? That's one thing you can do with them. By the end of the week, you'll know how to solve something like that. Now, how come you could solve, or hopefully you could solve that one, but maybe not that one? Yeah? It's all right. How come you could solve this one? Now you have odd numbers.
Because you could do 3 to the second equals 9. It's a multiple.
A power. Okay. So if this number is a power of that number, so if I put like a 4, an 8, a 16 here, the answer here is easy to figure out. Okay? Or same thing on this side. If I put anything that's a power of 3, 9, 27, 81, you can figure it out. The problem happens when you have a number here that is not a power of the base. Then things get a little tricky. You can kind of guess it should be between 2 and 3, but we don't know exactly unless we use what's called a logarithm. So those kinds of problems that I just showed you, those were called exponential equations. What's even simpler than an equation is take out the other side and just write something that has a power that's a variable. Okay? That's called an exponential expression. Okay, so exponential expressions, basically any expression that has a variable as an exponent. And there's 2 examples. So in algebra, we're not going to go into it as much here, but you may have learned that there's a connection between exponential expressions and logarithmic expressions. Okay? There's a way to change one into the other. Okay? And that's what I'm going to show you next. Okay? A lot of times, if you have an exponential expression you can't solve, you change it into a logarithmic expression, and vice versa. Okay? If you have a logarithmic expression you can't solve, a lot of times you change it back to an exponential expression. Okay? And the difference between the two is when you write something as a logarithmic expression, okay, it's going to look like that. A logarithmic expression has the word log. Okay? An exponential expression has something like this. Okay, it has an exponent. Sometimes the exponent is a number. Sometimes the exponent is a letter. But either way, they're both exponential expressions. Okay, I'm going to show you how to change from one to the other. And there's a formula you can use, and basically there's three things in the formula. You just have to look at where the three things go when you change between exponential form and logarithmic form. Okay, so on the left, I'm starting with an expression in exponential form. It says x equals a to the y. Okay, how do I know it's exponential? I've got an exponent. Okay, Marquise, what letter there is the exponent?
Y.
Yeah. And do you remember what you call the thing that's lower than the exponent? Specifically, like, what would the 3 be called there? The thing that's lower than the exponent. Not sure. Anybody help them out? What's the thing that's lower than the exponent? Sometimes it's a variable, but sometimes it can also be a number. In this case, it's a variable, but not in this case. It's called the base. Okay, and it's important to know what the base is, because when we start changing things to a logarithm, we're also going to say the word base a lot. All right, so there's three things here. That's your base. That's your exponent. And the x, that's the thing on the other side. That's all I got. All right, so we've got a is the base, y is the exponent, and then x is the thing that's on the other side. So when we change it to log form, first thing you want to do is write the word log. This is called the base of the log. And it's nice that they call it that, because we call it the same thing when you write it as an exponential. It's the base on the exponent. This is the base on the log. This was the exponent. So when you rewrite something as a logarithm, the exponent goes by itself on the other side. So when you rewrite something as a logarithm, the logarithm always equals the exponent. Okay, so whatever the exponent is, put that all by itself. Okay, and then if you know that a is the base, and you know the exponent always goes by itself on the other side, there's only one thing left you haven't used. That's the x, and that goes right there. That is your argument. Okay, we've seen arguments before, like if you take the sine of 10 degrees, 10 is the argument. It's just the thing that you're plugging into the sine function. You could type it in log of 10. Okay, it's not degrees. We're not working with angles at all. But 10 is the thing that I just took the log of. Okay, so that's called the argument. And the way you pronounce what's on the right-hand side is y equals, or you could say y is, same thing, the log base a of x. So I like to just show people, like if you were writing this on lined paper, this is how it would look. If you wanted me to write log, say base 2 of 3, it would look just like that. There's no exponents in this. Okay? X is not an exponent. That would be an exponent. That's log base 2 of 3 to the 5th power. Okay? But just like this, no exponents. The 2 is actually written a little bit lower, and the 3 is right on the line with everything else. Okay. Any questions on how you pronounce that? Okay, Dan, how about how would you pronounce that? There's no y equals this time, so it's just kind of the second part of what I wrote. Oh, you don't have to rewrite it. I just want to know, like, if somebody wrote that on paper, like, how do you pronounce that? Like, if I wanted you to write that on paper, how would I say it to you? Not quite. Sam?
The log base of x, no, log base x of 6.
Yeah, this is log base x of 6. We couldn't find out what that is unless we knew x. Okay? You'd have to know that. This one I could type into a calculator. This one I can't because it has a variable. Okay, but that's log base x of 6. How about... Skylar, how about that one? How would you say that one?
Y equals the log base A of R.
Perfect. Y equals log base A of R. Yeah. Okay, any questions on how you write it on paper or how you pronounce it? All right, so now what I'll do is I'll start you off with one of these two, and we're just going to practice changing something from exponential to log, and then we'll try the other way as well. Okay, so the first type, we're going to practice changing something that's log into exponential. Okay, well, when you want to change to exponential, there's three things. There's a base, there's an exponent, and then there's something that goes on the other side by itself. So when we're done, those three boxes should be filled in. So we just have to figure out where the three things in our problem, the 3, the x, and the y, where they go in these boxes. Right, let's start with the 3. Okay. John, do you remember what the 3 is called?
The base.
It's the base. So when we write something as an exponential, would it go in the black box, the blue box, or the red box? Yeah, the black box, that's the base. Okay, so there's my base. And now earlier I said that the logarithm always equals, what's this number that's always by itself? That's always the exponent. Okay, so logarithm always equals exponent. Okay, and Shakira, what box here is the exponent? So the blue one, logarithm equals the exponent. So y is the exponent. Now we've only got one letter left, and we've only got one box to put it in. Okay, so Kyle, what's going to go in the red box? X. That's it. That's the answer. As far as getting something numeric, we can't. If you told me what y was, then I could. Like if y was 2, I could do 3 to the second power and get the answer. But that's all we can do. Any questions on that? All right, let's try this one. Y equals log base 5 of x. I put the boxes down the first time just for you to see it, but you don't always have to write boxes. You can just write your final answer. Okay, Alyssa, what's my base here? Yep. Base is 5. Okay, so I've used the 5. And Karen, logarithm always equals what kind of exponent? Oh, logarithm always equals what kind of number? It's always the exponent. So in this case, the exponent is y. And if you can remember those two, there's only one thing left, and that goes on the other side by itself. So how about, Eric, what's going to go on the other side?
The log. X.
X. Okay, and again, there's nothing to solve there because you have two variables. Unless you know what y is, you can't really do anything with it. So you just stop there. Okay, any questions on changing from something that has a log to something that doesn't? All right, so let's try it the other way. Okay, this one I want to change to something that has a log. So if I'm going to change this to a logarithmic expression, what do you think the first thing I'm going to write down is? Even before that, think of what we're changing it to, a log. So the very first thing you should write down is the word log. And now you have to fill in three boxes. Something here, here, and there. So John, you had started me off. What did you say this box was?
30.
Yep. The logarithm always equals the exponent. And Nick, how about the base on my log?
1.2.
Yep. The base on my exponent was 1.2. That's also the base on my log. Okay, and Katrina, what's the only thing I haven't used? M. And that's the answer. 3 equals log base 1.2 of m. Now, in this problem, there really wouldn't be a reason to do what we just did, practically. If you had this, this is a better way to write it than this. That's not always true, but in this one, it would. We're just practicing changing it into a log. All right, let's try this one. It says e to the b equals 9. Okay, so Nolan, what's first thing I should write down? That says, yep, e to the b equals 9.
So b equals
Log.
e.
I'm just not sure. Did you say base anywhere? You got to have a base in there somewhere.
Oh, with e.
Yeah, the base, log base e of 9. And that's it. So b equals log base e of 9. I'm going to come back to this one in a little bit. Okay? For now, I'm just going to leave it like that. But this is something you would probably never see written in a book. They would go one more step. And I'll show you what that is in a second. Okay, let's try this one. Okay, a to the 4th equals 24. So Claire, could you tell me what's going to be by itself on the other side? Yep. Okay. Logarithm. We always put the 4 by itself. And Jasenia, what's going to come after the equal sign?
Log.
Yep. Always got to put the word log. Okay. And my base. How about Paige? What's my base here? Yep. Base A of Jesse, what's going to go right here? 24. And do you remember what that 24 is called? That's the argument. It's the thing that's being plugged into the log function. You're taking the log of 24 with a special base that we don't know. Right. So any questions on it? So this is one that we're going to change to an exponential expression, and then I'm going to show you on the calculator how you can type it in. The way it's written right now, this isn't something we can type in. But if we do what the directions are asking us to, then you can. So Rebecca, what's my base here? Yeah, E. And how about Marquise? What's my exponent? Yep, -3. And that's going to equal, Kyle, what haven't I used? B. Now, I said to you, you could type that in on a calculator. How come I can type that in? I have 2 letters. How am I going to type E in on a calculator? Anybody know anything about E? Okay, we're going to talk about what you just said in a second. But E is kind of like this. Yes, it's a letter, but it stands for something, right? So like this stands for 3.14. Well, E is the number 2.718. And it goes on from there. Okay, but E is about 2.718. And most calculators have a button you can press, and it'll tell you what E is. On mine, it's second, and then it's the division sign. If you're using a non-graphing calculator, I can help you find it. But it's probably there somewhere. It looks like there's a pattern to it. 1828, 1828, but it doesn't keep repeating 1828. In fact, I think this calculator might tell me more digits for E if it has it on it. Actually, if you use this calculator, I don't see E on it. Does anybody use their computer for a calculator at home? Like this calculator? No. And it's not that button, F-E, that's different. So. Nope, there's no E on that one. But the point is, if I asked you to type that in, I have on my calculators, you can type E on it. You just press second, E to the -3rd. So if I wanted to know about what that was as a decimal, it's about 0.050. If you round to 2 places. 0.050. And since E actually stands for this number 2.718, I told you that I would come back to this one in a little bit. Okay, and it's going to tie in with something I think Jake mentioned it. You said, what did you call this? This E, it had to do with what? Natural. Something with the word natural. Okay. People heard that term before? Natural logarithm? No? No, you're the only one. But yeah, it has something to do with the term natural logarithm. Okay, and I'll show you what that is. Okay, in a little bit. It does have to do with having a certain base, but I'll get to that. All right, so this one says it's basically like solve. Okay, I want you to solve for x. Now, in general, you can't just solve any log problem in your head. Okay, but I haven't shown you how to type very many things into the calculator yet. And this I haven't shown you how to type in. So when we do this out, it's going to work out to a nice answer. Okay, it's going to be something you should be able to do in your head. Bless you. Okay, does anybody have any suggestion on what I do to this to try to solve it? We don't know how to do much with logs, but we know how to do one thing so far. Yeah? Yeah, let's just try changing it. Let's change it so it doesn't have the word log anymore. So could you tell me, Shakira, how that would change?
It'd be 2x equals 16. Well, I mean, exponent is x.
Yeah. So if you change it to an exponential expression, it says 2 to what power would give you 16. And I told you this would work out nice because you don't know how to type it in yet, so it has to work out to a nice answer. So what would you get? 2 to what power is 16? 4. Yep. And that's it. Now, if I change that 16 to a 15, now you've got a problem. Okay, something we might not know how to do yet. Okay, but for now, I would leave it just like that. All right, let's try this one. I want you to evaluate that. I want to know what is the answer to log base 5 of 25. Just like doing that. Okay, so John, how would I write that in a different way?
It would be 5.
Yep.
X. Power. No, 5. To the power of x.
Mhm.
25.
Okay, so we've rewritten it without the word log. It's the same thing, just rewritten differently. But now we've written it in a way we can hopefully figure out x. So what would x be here? 2. 5 to the second power is 25. Now, sometimes people here say, oh, x is 5. What's the mistake they made if they say x is 5? What do they do? Yeah? Yeah. You're thinking of this, which is not what we did. Okay, 5 times 5 is 25. 5 to the second power is 25. Okay? So just be careful with that. All right, so now, whenever you have a argument that's a fraction, something is going to happen, okay, when you get the answer. So what I want to do for a second is pretend that we were solving this problem. Okay, if I was going to solve that, it would be 3 to what power gives me 27. Now my problem is a little different. It's 3 to what power gives me 1 over 27. If you can figure out the answer to this one, then you'll be able to figure out the answer to this one. They're very close. Okay. What power do you raise 3 to get 27? Yeah, this is 3. So that's the answer to this one. Now, I don't want to get 27. I want it to flip. Does anybody remember what kind of number you have to have in an exponent that causes it to flip? Yeah? A negative. So what would be the answer here? Negative 3. Okay, so if you want to get something that's a fraction, your answer needs to be a negative. Okay, and what's nice about a logarithm is you could check it. Let's type in 3 to the negative 3, see what we get. I get that number. Let's type in 1 over 27 and see if they come out equal. Yeah, they do. So negative 3 is the correct answer. Any questions on that? If you want to get a fraction, just make sure you make the answer negative. But other than the negative sign, you solve it just like you would if it wasn't a fraction. You just have to remember to put a negative in front when you're done. All right, so we already kind of mentioned this earlier, but E stands for a number. When you're talking about logarithms, it stands for the number 2.71828, and it keeps going, but it doesn't repeat. It's kind of like pi. Now, exactly where this comes from, this 2.718, that's kind of complicated. Okay, and for this class, we really don't need to know why we have that number. It's just that's the number you have. And if that number happens to be your base, okay, you can have any base you want on a logarithm. You can have base 2, base 5. But if you happen to call it E, okay, if you use that as your base, that's something special. Okay, that's called a natural logarithm. Okay, so someone mentioned that earlier, but anytime that your base is E, that's called a natural logarithm, and we use this abbreviation, LM. So you usually would never see something like that written on paper. Anytime you have log base E, they're going to shorten that to just LM. And your calculator does the same thing. You have a button right below the log button that says ln. And that stands for log base E. So, anywhere you see log base E, you can change it to an ln. So, going back to that problem I mentioned a little earlier, you wouldn't see log base E written in the final answer. It's not wrong, it's just not simplified. You would see this. They would replace the log base E with an ln. And now that's something you can type in on the calculator. If you want to know what the ln of 9 is, you can type it in, and the answer is about 2.2. Okay? So anytime you see log base E, change it to ln. So on most calculators, there's only 2 logs that you can type in directly. This is one of them. You can type in the natural log to a calculator, as long as you have a button that says ln. If you don't have an ln button, then chances are you probably don't have the one above it either. Okay? Probably your calculator can't do logarithms. Okay? This calculator, in this mode, can't do logarithms. You have to have a scientific calculator. Okay, and on mine, there's the log button, and there's the ln button. It's up at the top. The only thing that can be a little tricky about this abbreviation is it hides the base. So you've got to remember when you write the words ln, that stands for log with a base of E. Okay. So ln hides the base. All right, so there's one other special logarithm we can type in. Okay, and that's called the common log. Okay, so common log and natural log, those are the only two logarithms you can type in on a calculator directly with one button. So common log has a base of 10. Natural log has a base of e. So how would I type in something other than those two? Well, I'm not going to show you that today, but you can. Yeah?
I thought you had some questions.
Oh, do you know how? Yeah, there's a way to do it. That's an example of a common log. Why? The base is a 10. That's also an example of a common log. Because common log is used a lot, you don't have to write the base. So anytime that you leave the base blank, that's okay, as long as it's supposed to be a base 10. So if you don't fill in the base, I'm going to assume you mean 10. It's kind of like if I put an X and I don't put a number in front of it, I assume it's a 1 if you don't put anything. Same idea. Okay, so if I ask you to take the natural log of a number, what base is natural log? E. If I asked you to take the common log, that's base 10. And those are the only two that you have buttons directly for on the calculator. But now I'll show you how you type them. Let's do a natural log. Does everybody have this? Okay. So here's a problem with a natural log. ln of x equals 8. Now, if I ask you to change it to an exponential expression, there is a base here. And I asked you just a second ago what it was, but it's hidden. Okay, what is the base when you write ln? E. The base is e. And the number that's by itself, that always becomes your what? That's your exponent. And what haven't I used? The x. So the answer to this problem is whatever you get when you take e and raise it to the 8th power. So you could type that in. I'm not going to type it in. But you could see what it comes out to. Okay, and let's do this one, but let me just write it as a log. Okay, so that was a natural log. This is a common log. What would this be if you change it to an exponential expression? Okay?
10 to the power 12.
Yeah. Whatever 10 to the 12th power is when you do that on the calculator. Now, where'd you get the 10 from? I don't see 10.
Because it's not there, so you just assume it's
Yeah, if the base is not there, you assume it's 10. That's what we just went over. Generally, when the numbers start to get this big, we don't do them out. If you were to type in 10 to the 12th power, it's, actually, let me do it on this one. It's going to be pretty big. So it's a trillion. So we just leave it as 10 to the 12th. Okay? I wouldn't expect you to do this out on a test. All right, so now I want to finish up with solving a couple of log equations. To solve this equation, you don't need to know anything else except how to change that to a different form. And then maybe some basic algebra 1 stuff. Okay, so to solve that equation, you're going to change it to exponential form. And that's going to get rid of the word log. So it might look kind of confusing right now, but I guarantee if you change it to exponential, everybody should have a good idea of how to solve it. Okay, before we change it, let's just identify what's what. Okay, just anyhow, what's my base here?
No, three.
3. Base is always the number that's written lower than everything else. Okay, so that's my base. Claire, what's this 2 going to turn into? It's the number that's by itself. Yeah, that's going to turn into an exponent. And then the only thing I haven't used is this 4x minus 7. That's all stuck together. That's the argument. Okay, so let's rewrite it. 3 is my base. 2 is my exponent. And the only thing I have left to go on the other side is 4x minus 7. Okay, any questions on how I changed it from something that had a log to something that doesn't? Okay, and that's basically it as far as what I taught you today. Now from here, you have to know how to simplify and solve that. But Nick, what would you do next here?
Turn in 3 to the second to 9.
Yeah, why don't we just do that out? So I have 9 equals 4x plus 7. Nolan, what would you do after that? Well, you got to get that x by itself. So what are the 2 things that are on the side with the x?
7.
Yeah, the 4 and the negative 7. Why did you decide to add the 7? Why not move the 4 first? You just picked it? Anybody know why? You do have to do, I agree with that though. You do have to do the 7 first. Why can't you do the 4 first? Yeah, Sonny? Exactly. It's the number that's attached to the variable. Okay? You always do the number that's attached to the variable as the very last thing. So add 7. It's going to give me 16 equals 4x. And now we can get rid of the number attached to the variable by doing what? Divide by 4. So what do I get for an answer? Yeah. X equals 4. Okay, so once you change it into an exponential, you have to just know your algebra 1 steps. Okay, and x is 4. Okay, so in that last problem, the variable was in the argument. Okay, somewhere in the argument. Where's the variable this time? It's in the base. But that doesn't change anything we're going to do. We're still going to solve it exactly the same way we started the last one. So Kate, what was the first thing I did in the example we just did?
You changed it.
Yeah, I changed it. So I'm going to do that here. I'm going to change it. Can you tell me what I get when I change this?
X 2 equals 64.
Yeah. We get x squared equals 64. Now, I don't want x squared. I want just x. So what do I have to do to get x by itself? Yeah, I take the square root. The square root, that's the opposite of squaring. And now when you take the square root of 64, there's technically 2 numbers that multiply to give you 64 that are the same. What's one of them? 8. 8 times 8 is 64. And what else? Negative 8 times negative 8 is also 64. But when we deal with logarithms, the base cannot be negative, ever. Actually, neither the base or the argument. So we're going to ignore the negative answer and just write the positive. X is 8. Okay, so we looked at a problem where the variable was in the argument. We did one where the variable was in the base. And whenever that happens, you're going to have to take a root of each side. If this was a 3, you'd be taking a cube root. If this was a 4, you'd be taking a fourth root. Okay, but whenever that's a base, when the base is a variable, you're going to have to take a root. Okay, and now the last type, here's an exponential one. We've got a variable in our exponent. Now what's different here compared to examples A and B? I can't really get them on the screen at the same time, but there's example A, there's B, and then C is different. Does anybody see what's different about it? Yep. Okay, so we have a number and a variable in the exponent. Anything else that's different? Yeah. It has E. That's true. None of the other problems had an E in it. What is something that A has and B has that C doesn't? It's a log. This is not log form. What format is this? This is exponential. So the other two, we started in log form and we changed to exponential. This one, we're going to do the opposite. We're going to start in exponential and change to log. Okay. Since I'm going to change to log, I'll just start by writing the word log. And Brian, what's my base here? Yep. My base is E. We'll come back to that in a second. And when you write something as a log, what goes by itself on one side? The exponent, which is 2x. And the last thing is the 5, and what's the 5 called? Perfect, yeah, that's my argument. Okay, so everything we did there, that's fine, but there's something we can write a little shorter. Yeah, what can I change to ln? Log base E. We can change that to ln. So now my equation says that 2x equals ln 5, but I want just x. So what's my last step? Yeah, just divide by 2. And that's the answer. It's the natural log of 5 divided by 2. If they said round your answer off, you just type it in. Take the natural log of 5 and divide by 2. It's about 0.805. Now, would it make a difference if I didn't close that parenthesis? Yeah, if I didn't close the parenthesis, what it would do is, it wouldn't do the natural log of 5. It would do the natural log of 5 halves. That's like doing the ln of 2.5. That's totally different. Okay, so make sure you do close that parenthesis. Okay, so any questions on that? And just kind of a little bit of basics about logs, right? So tomorrow we'll get into doing a little bit more with logs, and then on Thursday, kind of combining everything and a little bit of review for the test on Friday. So the homework tonight, it's on 473, and it's all evens. Okay, everything you see there is just the evens. So 10 to 16, 22 to 28, 34 to 38, and 92 to 98. Got a little under 15 minutes left. So I'm going to get some textbooks, and if you need one to start working on the homework, you can just come up and grab one.